Hi, I'm Tim Berglund with StarTree. Welcome to Pinot 101, Batch Ingestion. Now, there are two ways to ingest data into Pinot: batch and streaming, or what we sometimes call offline and real-time. And in this module, we're going to look at offline, or as I prefer to call it, batch. Now, conceptually, I've got some kind of data, whatever that data is over there, some list of student IDs, other columns. I'm ingesting that into a table, and that data is off there, stored somewhere. It's in my file system, and maybe it's in a legacy HDFS cluster, it's in a cloud blob store, it's somewhere, and I'm gonna spin up a minion task to read through that data and create segments and load those segments into the cluster. And this, logically speaking, this table is composed of those segments. And if I had many rows, more than 4 rows, I might have lots and lots of segments. So logically, they're like this, that table is composed of those segments. On a more physical level, of course, remember those segments are stored on servers. We've covered this architecture in another module in the course. But just as a brief reminder, those segments are stored on servers. On a logical level, it's the table that's composed of the segments. Let's look at how we actually do this. So here's our data. Yeah, I know there are only 4 rows. It doesn't look like a real big data problem, but it does fit on the slide. So here's our data in CSV format. That's one of the natively supported formats by the data ingestion tasks that come with Pinot. So if you literally had a lot of CSV data, you wouldn't have to write any code. You just have to do a little bit of configuration to get it imported. You'd begin by creating a schema. And this is not an exhaustive study here of the schema file format, but I want you to kind of wrap your eyes around it. I want you to see what it looks like. You give it a name, you give it dimension field specs, student ID, first name, last name, those all have data types, and metric field specs. In this case, the metric is score, and that's of type float. And of course, you need to have a date time field in there that's required for a Pinot schema, and that is called timestamp in epoch is our excellent name for that column. So this is our schema. We start with a schema in JSON format, very readable, very nice, love it. Table configuration, often just called table config, is a place you're going to spend a lot of time in your Pinot life. This is where really a lot of our work in defining what a table means and how it works takes place here. This specifies that this is an offline table. It's not a real-time table, so this is a table where we're ingesting batch data. We configure tenancy, we configure some things about ingestion. This is really kind of a minimum subset table config. It gets potentially much more complex. But again, in the spirit of me just wanting to wrap your eyes around what does a table config look like, what's in it, this is a very basic table config. Now that I've defined the schema and the table config, I have to create the table, and I can run this command line tool to do that. This will communicate with the REST endpoint on the controller to create the table, and that's really just establishing the metadata. Next up, we run this command to actually ingest the data. This command, believe it or not, is going to go kick off a minion task to read in that voluminous CSV file, create the associated segment, and push it into the cluster. What does that really mean, push it into the cluster? Let's kind of look at our cluster components here, and at a very high level, look at what's going on. So when we run the ingest, the controller kicks off a task and says, this minion worker, I want you to go do this ingestion task with this CSV file. All that config goes to it, knows how to get to the file, and so that minion worker is now running. It creates, in storage that it has available to itself based on its own configuration, a segment. Well, it's made a segment. What does it do? Well, it pushes that segment to the controller. There are a few different ways, kind of at a physical level, that can actually work. And one is literally, it can upload a tarball of all the segment files to the controller. And the controller says, thank you, I now have a segment. I'm going to pass it off to a broker that I have. And as we go on creating more segments, there are other ways to do that. Again, if you deep dive into how the controller works, the minion may put that segment file in a network addressable place and simply give the controller a URL and say, hey, by the way, I've got this new segment. You can go get it from this place. And the controller doesn't really need to take the whole file into its own storage, but it can then pass that URL and sort of transfer that file to the server. And that server very much will be storing it locally. So no matter what, when we're creating new segments, as many as we create, they will end up stored on servers. That is the end game here. And the minion worker, the controller, kicks off the minion task. The minion task does the ingestion, the work of creating the segment file, and works with the controller to push it into the server. Works with the controller because the controller is the one responsible for deciding where segments even go. That poor minion worker can't know that. The controller is the only one with that view. So the batch ingest process relies on going through the controller. Whether the bytes of the segment file themselves go through a network interface card and onto storage on the controller itself is not the point, but the controller makes the final decision. So that is batch ingest from a very high level kind of command line standpoint. And architecturally, what are the components of the cluster involved in the process? That is how that works, and that's the foundation of the way offline tables are created in Pinot.